Hello, Professor Pietrosemoli. I'm Lynn from BTW Media. It's my pleasure to meet you, and I'm truly honored to have you to join us for our History of the Internet series. In this project, we speak with pioneers and innovators who helped shape the Internet across different regions of the world, and your stories is an important part of that history. Before we begin, could you please take a moment to introduce yourself to audience?
Okay, my name is Ermanno Pietrosemoli. I am currently a researcher at the International Center for Theoretical Physics in Italy, but I was a professor of Telecommunications Engineering at Universidad de los Andes in Mérida, Venezuela, for 30 years.
Thank you for your introduction. The first question is about beginnings and first encounters. When and how did you personally first encounter the idea of the internet? Could you recall what you were working on at that time and what made you realize it could be transformative?
Yes, in 1919, I was a professor of telecommunication at Universidad de los Andes in Mérida, Venezuela, where I headed the telecommunications lab. In that occasion, a friend of mine in the US told me about the internet, and that raised my interest in the subject because at the time we had very little communication. The telephone communication was very expensive, and so was fax, and that was available only in the university. So the idea of a different communication media that could be used for many type of communication was really interesting. Later, some colleagues from our university were able to make a connection to a server in Caracas, the capital, in which they had a connection to the internet. But it was not a real internet connection because it was a delayed connection using a protocol called UUCP, Unix to Unix copy. And that way, we just made a telephone call once a day from Mérida, which is inland, about 600 kilometers from Caracas, to the capital. And during this daily telephone call, we would send all the messages that were queued in our server to the server in Caracas, and from then it eventually reached the internet, but on a delay time. This type of connection nowadays would be called a delay-tolerant network, although at the time the name was not used.
The second question is building the first connections. You helped bring internet connectivity to Venezuela and other parts of Latin America. Could you describe what you personally did in those earlier projects? What it felt like the first time you saw a successful connection?
Well, in 1991, I had a sabbatical leave of absence from Universidad de los Andes, and there was already a lot of internet interest for Latin America. And I had contacted Professor Glenn Reichert, which was at the University of Maryland in College Park. And he was the principal investigator of SURANET, the Southern University Research Network in the southern states of US. He was very active promoting internet connectivity in South America, and he invited me to spend some time at the University of Maryland. He also introduced me with Saul Hahn from the Organization of American States, who had launched a program called Red Hemisférica Universitaria de Ciencia y Tecnología, aimed at fostering internet connectivity in Latin American universities by means of satellite technologies, launching from a hub in Homestead, Florida. Saul told me that the Organization of American States had donated a satellite ground station, what we call a VSAT, to the Venezuelan organization responsible for networking research. At the time, it was called SciSit, Sistema Automatizado de Información Científica y Tecnológica. He also pledged support from the Organization of American States to the networking training activities in Venezuela. I also spent part of my sabbatical at the International Center for Theoretical Physics, where I am now, and participated in the organization of the second International Networking School in early 1992, with the intention of replicating that activity in Venezuela. Some of the lecturers at the ICTP event, including Steve Goldstein from the National Science Foundation in the US, agreed to collaborate on the training activity to be held at Universidad de los Andes. Consequently, in November 1995, we organized the first Escuela Latinoamericana de Redes, EsLaRed, with 45 participants from 10 countries in Latin America and the Caribbean. This was the first activity that was of international scope from the viewpoint of internet connectivity in the whole region, because we had participants from 10 different countries in Latin America. And the instructors were from Latin America, from Europe, and from US.
The third question is overcoming early obstacles. What were some of the toughest moments you personally faced, whether technical, political, or logistical, when trying to connect people to the internet? How did you and your team manage to solve them?
Well, the Organization of American States had donated a satellite ground station, a VSAT, to the Venezuelan government, but this was never put to use. So I started thinking, how can I get hold of that ground station? I found that it was still in the original crates stored in Caracas. So I decided to organize a training activity on satellite communications in my own universities. I had a friend, his name is Ernesto Lorenz, who worked in a satellite company called Bantel, and he offered to lead the training of on satellite technology in our university. So I wrote a letter to the person in charge of the VSAT station that was stored, and asked a loan of the same in order to carry out the training activity in Venezuela. So they could not refuse, because I knew that it was stored there, nobody was using it. So I said, okay, you should loan it to our university in order to carry out this activity. So we were able to obtain this ground station, this VSAT station. We installed it in the roof of my laboratory, and actually the modem was installed directly into my office. And we carried out the training activities. And after that, I was able to convince the rector of our university, the president in English of our university, which at the time was called Henry Vargas, and that connecting the university to the internet was really worthwhile, and he agreed to pay the substantial cost of the telecommunication through satellite. We had the ground station, but there was still the obstacle of paying for the connectivity. So the rector I was able to convince the rector, and they signed a deal with the PanamSat, the satellite company, and we were able to connect our university at the speed of 128 kilobits per second directly to Homestead, Florida, and from there to the rest of the internet. So that was quite interesting, because at the time, the only communication for the whole academic network institutions in Venezuela was by means of a telephone modem from Caracas at the speed of 19,200 bits per second. So we were very happy to be able to have a much faster direct connectivity. And we share that with the rest of the academic network in Venezuela that was called Reaction, Red Académica de Centros de Investigación y Universidades Nacionales. So that was a little indirect way, but we got the job done.
The first question is the wireless breakthrough. You led pioneering work on long-distance Wi-Fi, even setting a world record. Could you take us back to that moment? What challenges did you face, and did it mean to you when it finally worked?
Well, the serendipity moment came when I was visiting a beautiful village in a rural area in Mérida and asked myself, what would I need to move to such a place? And the answer was a good means of communication. At the time, the telephone network in Venezuela was restricted to the cities. So the only way to have communications in remote areas was by means of your wireless technologies. As a radio amateur, I had been using a technology called packet radio, which allowed for the connection of a PC to an analog radio transceiver by means of a special purpose device called TNC, Terminal Network Connector. So I started exploring means to adapt this technology for the purpose of providing internet connectivity to remote places. The transmission speed was limited to 56 kilobits per second, and only licensed radio amateurs were allowed to use the system. But we were able to connect some remote facilities at the university internet. A breakthrough happened when the Venezuelan spectrum regulator, following FCC examples, allowed the use of the ISM bands, industrial, scientific, and medical bands, for communication purposes, using spread spectrum modulation. I bought a pair of wavelength cards that implemented spread spectrum modulation and were to be attached to the main board of a PC and fitted with small patch antennas. They were meant for short distance communication at the speed of 1 megabit per second. But my idea was to hack them and in order to be able to span a longer distance. And for that purpose, I built a couple of Yagi antennas to substitute for the patch antennas and was able to prove long distance communication at greater speed and without the need of radio amateur licenses. So this was a very pivotal point because we had a technology that could be really deployed on a wide scale and was able to provide at the time a very substantial speed of connectivity. Therefore, we undertake a project to provide internet access to most of the state of Mérida using spread spectrum and later on other broadband technologies. Initially, this project was financed by the university, and then it was financed also by a research organization in the state. So we were able to cover the whole state of Mérida and reach very remote area using wireless technology and using repeaters in places in which that provide good. A breakthrough happened when the Venezuelan spectrum regulator, following the US FCC example, allowed the use of the industrial, scientific, and medical bands, ISM, for communication purposes using spread spectrum modulation. I bought a pair of wavelength cards that implemented spread spectrum, and they were to be attached to the main board of a PC and fitted with small patch antennas. They were for short distance communication at the speed of 1 megabit per second. The purpose was to build a local area network without the need of laying cables. But I thought that this could be repurposed for long distance communications just by changing the antennas that they were using and changing the communication protocol. Therefore, I built a couple of Yagi antennas and removed the patch antennas. And with the Yagi, I was able to prove long-distance communications at much greater speed and without the need of radio amateur license. So this was the point at which I think that the dream of connecting remote connectivities was going to be feasible. Therefore, I undertook a project to provide internet access with the funding from the university. We were able to build a network that reached most of the state of Mérida using spread spectrum technologies to connect not only laboratory outposts of the university, but also schools and hospitals and other places and other institutions that wanted to participate in the program. In 1996, ICTP sponsored an international team to design a network at the University of Ile-Ife in Nigeria. ICTP was providing internet access by means of a telephone modem, but they wanted to share this connectivity among several buildings in the campus of the university. The original idea was to use fiber optics to connect the campus, but I proposed to use the wireless technology that we had deployed in Mérida because it is much more cost effective, and therefore the project went along in this direction. And the University of Ile-Ife was the first to be connected by means of wireless technology inside the campus, whereas the internet access was by means of telephone, international telephone communication. Okay, so this is an example of how the idea of wireless technology could be used not only in our own country, but also in this case in Africa. So I started thinking about what is the limit of distance that you can reach using wireless in the ISM bands. At the time, we were using 900 megahertz and then 2.4 gigahertz, the frequencies that are part of the ISM. After successfully spanning a distance of 70 kilometers, I started exploring scenarios that allowed for an unencumbered line of sight and found one of 280 kilometers that took advantage of a location at an altitude of 4,100 meters in the Venezuelan Andes that allowed clearance of the Earth curvature to the other end that was at a height of only 125 meters. But the terrain was flat in between those points, so the Earth curvature could be cleared without obstacles. The experiment took place in April 2006 using the antenna from the satellite ground station that was no longer in use, that had been decommissioned and substituted by a fiber optic to the network in the interim. And we use inexpensive Link 6 WRT54 routers to do this experiment in 2006. That was the first long distance experiment. We later broke this record exactly 1 year later in April 2007 and we were able to reach 380 kilometers by moving the remote site to a 1,500-meter high hill in the remote place. This is how we were able to establish the possibility of using Wi-Fi modified equipment to reach very long distances.
The fifth question is milestones in Latin America. From your own experience, what events or projects do you consider turning points in Latin American internet history? Moments when you personally feel, yes, this is really taking off.
In 1998, the Internet Society sponsored the first workshop of America Latina and Caribe in Rio de Janeiro, which was organized by EsLaRed. Lectures were in Spanish and Portuguese, and that was a really turning point for our perspective because the activity was supported by the World Bank, which meant that internet in Latin America had reached the mainstream. We had participants from all over Latin America and instructors as well from many countries in Europe and US, and of course, Latin America itself. And from then on, we have been doing training activities in many countries, drawing from a group of enthusiastic instructors that donated their time to this effort. Even today, after so many years, we are still conducting this type of training activities because we believe that training is the most important part. Technology can be bought, but if people are not trained, they will not be able to take advantage of the technology. So we continue with this networking training activities, and this year we will have the yearly activity of Escuela Latinoamericana de Redes.
The sixth question is working across borders. You have collaborated with organizations like ISOC and NSRC to train engineers across Latin America. What were those workshops and field experiences like for you personally? Any particular story or encounter that stayed with you?
Yes. In 1993, Escuela Latinoamericana de Redes was held in Peru and was the first training activity outside the Venezuela that we undertook. And it was a very interesting experience. I covered packet radio as a way to bring the internet to places uncovered by telephone network. Another milestone was the design of a wireless network to connect 4 islands in the Galapagos archipelago using broadband technology. That was a very interesting project because the Galapagos, is a marvelous place. Many tourists go there every year, but the 4 islands that were visited mostly did not have a connection among them. So we designed a wireless network in order to provide this connectivity. And a few years later, we also installed a local network at the Charles Darwin Foundation in Santa Cruz, in the main island of the Galapagos. And that was very important for their research activities.
The seventh question is reflection and hopes. After decades of being part of this story, how do you personally view the internet today? What still gives you hope, and what worries you most about where it's heading?
Unfortunately, from a platform of people exchanging ideas for mutual benefit to a medium often used for manipulation and spreading of fake news. I used to criticize TV broadcasting while extolling the early internet approach. Nowadays, the internet is even worse than TV regarding fake news propagation. My hope is that there will be a turnaround and people will start to carefully scrutinize the source of the information they are accessing in order to avoid the effect that we are seeing nowadays.
Thank you so much for sharing that. Your experiences and reflections have given us valuable insight into the history and future of internet development. It's been a really pleasure speaking with you. Thank you.
Thank you.